Here are the boundary F-scores. So there is quite some difference there. I'm very happy about this. The morpheme F-scores are also acceptable. Word accuracies, not so much, so every fourth word is not completely correct, but it's still better than nothing. And actually just skimming through the errors suggests that I'm already in the noise of the training data. So in some cases, my method actually fixes a mistake in the training data. So that's something I have to work on. And these were my highest scoring parameters. I tested a lot of different combinations. So for CNN and both LSTM, 20-dimensional embedding seemed to work. And 2 layers of CNN already performed pretty well, and three layers of LSTM too. So these were really close, actually. And for the reinflection case, the instrumental case, where I showed that you have to, from a noun, you have to guess how you would say it with that noun. And I actually got for word accuracy, there is no other measure that makes sense. Word accuracy is 90%, so that's already pretty good. Not at the level of a 4-year-old child, but it's not bad. And for the Korean segmentation, I got actually pretty high numbers for the boundary detection, and the word accuracy is 88%. So I consider that a pretty good result. And the conclusion is I implemented 3 supervised models for 2 tasks, morphological segmentation and reinflection. I tested and trained on 2 data sets. One is a Hungarian web crawl and the output of a rule-based analyzer, and the other one is a Korean segmentation data set. Of my architectures, the CNN performed best, but by not a large margin, so there's probably room for improvement in LSTM too. And my manual error analysis suggests that there is noise in the training data, so it's not perfect. It's probably at the disambiguation part, so that doesn't work very well. I have to come up with something to fix that. And my future work is, well, I have a ton of ideas. I want to improve the data set, fix disambiguation and use context, because currently I only use word forms. And thanks for Rishabh's suggestion that I should filter overlapping morphemes, not just overlapping words, but overlapping morphemes. This is pretty hard to do. My only idea right now is to separate the noun cases and train on one and see how it can generalize on the other, for example, for vowel harmony. Can it learn vowel harmony from half of the noun cases and do it on the other half? As for the model, I definitely want to debug the sequence-to-sequence attention. That's the most important. And Tommy suggested adding a unidirectional LSTM on top of the bidirectional encoder, which I'm going to try. And Ryan suggested CBHG from the Tacotron paper. And I also want to do decent learning rate scheduling. And my maybe more interesting is a better representation for assimilation. So what I showed in the instrumental case, actually just putting a space somewhere in the word is not sufficient. So we want to know that where do you put it really? Linguists would disagree where these segmentations are. And the long-term dream is to do this unsupervised. So just take a large amount of textual data and derive the rules. Okay, and I want to say thank you for everyone. I want to say thank you for my mentor. I want to say thank you for the organizers. I don't think everybody is there that I want to thank, but that was the best picture. And also for the participants, I think this is the best picture of us. Not everybody is here, unfortunately. But I had a great time, and I'm going to miss you guys very much. And thank you. This is the real pronunciation of my name. I think these are close.
Okay. Thank you, Judith. I thought Judith, but you did, right?
No, it's Judith.
Yeah. Any questions or comments for Judith?
First, I want to say I really like your presentation because first that you use the GPT representation extensions, yeah, which I like. and I'm primarily interested also in NLP. So I want to ask that if, in your model, like, did you use some like highway like connections, like vertical connections, and why you didn't use a conditional random field on the output of the LSTMs? And I would suggest that because to use a like transformer network from attention is all you need, because I personally I think it generalizes very well both RNN and CNN layer, especially from the character level or byte pair encoded like, data.
Okay. The first question was residual connections.
Yes.
I use them in the sequence model, but not in the RNN and CNN. Yeah, that would be a good improvement. So I'm going to do that. What was your second question?
CRF layer. Conditional.
Oh yeah, CRF decoding. I tried to use beam search now, but it didn't really work. It didn't work better than greedy decoding. I haven't tried CRF yet, but it's on my list. And you had a third question.
The last one is like more about suggesting to use a transformer network instead of LSTM.
I'm actually not familiar with that, but I will definitely look it up.
Oh, one other question. I did understand that at the last slide, one of your colleagues suggested to use a unidirectional LSTM on top of phi.
Yes,
and,
yes.
And what was the purpose of it?
It's his feeling. It's not a bug, actually. I realized later it's not a bug. Oh, we just need to rethink the architecture. It sounds like a cheap experiment.
Thank you.
I'm curious about how you embed the words, or did you embed the word?
No, I embed the characters.
Just process it by character.
Yeah, I use
right?
character embeddings.
Then how you input the characters into the neural network?
As a sequence of one-hot vectors.
One
or
of them.
indexes, as a sequence of indexes.
Yeah, it's a really impressive presentation. And, for the Hangul decomposition problem, have you ever tried a Python library called Jamo?
No,
Yeah,
no, I haven't.
Jamo is also a Korean name for vowels and consonants, and it's a really great library. You can handle any Korean decomposition or composition problems. And as you know, the current Korean parts of orthography, Hangul orthography, is quite misleading. So we always compose the Korean vowels and consonants into a separate syllable and a separate Unicode point, but it's quite misleading. So I think it's always a good idea to decompose Korean syllables into each component. I mean, the JAMOs. So yeah, it's really fun to use the Python library called JAMOs. I want to suggest you